So this video is on the reciprocal function. The general equation is y is equal to a, which is the stretch, times the divided by x minus h plus k. So a is our stretch. The x minus h, notice that it's in the denominator. So we can never have 0 in the denominator. So whatever makes this denominator 0, that is going to be our vertical asymptote. And then the plus k is going to move your graph up or down if it's a minus k. And that's going to be our horizontal asymptote. Our locator point, which is not a point on the graph, but it'll help us center our graph, is going to be, again, what makes this 0? H, comma, k. That will be our locator point. Now, I have an example of a reciprocal function here. Y is equal to 12 over x. Now, what you'll see is I multiplied both sides of the equation by x, fraction busting. So over here, these x's make a 1, cancel out, I get a 12. On this side, I get xy is equal to 12. So really, to graph this graph, I basically want my x and y coordinates. I want two things that multiply to get me 12. So 1 times 12, 2 times 6, 3 times 4, and so forth. Now, you also look at this and you'll notice that if I have two things multiplying to get me a 12, what cannot be true? Well, I cannot have either of them be a 0. So when I'm doing this, I cannot have x equals 0. Okay, I can't have x equals 0 because 0 times nothing will get me 12. 0 times anything will get me 0. Well, that's the same thing with my y. My y can also not be 0 because it would also be multiplying to try to get me a 12. So that's where our asymptotes are. Okay, our horizontal and our vertical asymptotes. Now, for this one, our locator point would be 0, 0. So let me just put a locator point in here. So at 0, 0 would be my locator point. Now that 0, 0, let me make that a little small, it's a little big. That 0, 0 is going to be where my vertical and my horizontal asymptote intersect. So x cannot be 0, so that means I have an asymptote at x equals 0, because that's going to make this an undefined situation. And x is 0 on the y-axis, because as I'm going up and down this y-axis, my x is staying constant, but my y's are changing. So this is x equals 0. And then this horizontal is going to be y equals 0. So let me put those in. Now I'm going to draw them with a dashed line. Okay. So for my vertical asymptote, again, it's going to be here at x equals 0. My horizontal one is going to be here at y equals 0. So let me just, and let me maybe extend this one here. Okay. So this line here, my horizontal one, is going to be y equal 0. My vertical one is going to be x equals 0. And you'll see that that's where they intersect, is at that locator point 0, 0. So now I am going to graph values that multiply to 12. So I'm going to be plotting, let me just kind of zoom in slightly here. I'm going to be going to 1 times 12. 2 times 6. 3 times 4. 4 4 times 3. 5 is not going to be times by a nice number, so I'm only going to do the ones that are going to be nice integers. 6 times 2, 7, I'm going to skip, 8, 9, 10, 11. The next one I'm going to do is 12, 12, comma, 1. Those multiply to 12. And so this is going to be one part of my graph. It's going to be 2 branches. This is going to be one part of my graph. Okay. Now, I can also multiply negative numbers. So I am going to go to -1 because -1 times -12 gets multiplies to a 12. -2 times -6, -3 times -4, -4 times -3, -6 times -2, and then I'm going to go out to -12 times -1 because a negative times a negative is a positive. And so I'm going to have this graph. And together, these 2 branches make up my reciprocal function. Now, I'm going to have one that gets shifted. So here, this one, let's say I have it as a -12. Okay. So what's going to happen is whatever makes this 0 is going to be the x-coordinate of my locator point, but also it's going to define my asymptote, my vertical one. And this +5 is going to be the y-coordinate of my locator point, and it's going to define my horizontal asymptote. So I am going to have a locator point of -4 for my x. That's going to be my x-coordinate, which means that is going to be my vertical asymptote at x equal -4. And then my 5 is going to be my y-coordinate of my locator point. And so that's going to be where my horizontal asymptote y equal 5 goes through. So I am going to plot that locator point at -4, comma 5. And that is where my horizontal and my vertical asymptotes are going to go through. Okay, so let's get a thinner font here. Okay, and make it dashed. So my horizontal one is going to be going through this at a height of 5. My vertical one is going to go through this at a -4. Oops, let me extend this out a little bit. Okay. So at -4. And I'm going to label those. We always label them. We label them with the equations. So this one here is going to be x is equal to -4. This one here is y is equal to 5. Now, I'm really at this point coming over to this location, and basically, because I've already moved it to the left 4, I've already moved it up 5. That's where I am. Think of this as your origin. And now I'm just trying to think of things that multiply to a -12. So when I plot this, and I'm trying to get things that multiply to a -12, let me just get this a little thicker. Okay, so -12, I'm going to go +1, and I'm going to go down -12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to go to 2 and then 2 away, and I'm going to go down -6 because 2 times -6. So 1, 2, 3, 4, 5, -6. I'm going to go 3 away, 3 times -4. So 1, 2, 3, 4. I'm going to go 1, 2, 3, 4 away, 4 times -1, 2, 3. I'm going to go 5, 6. So at 6, I'm going to go down 2, so -2. So that was 6, 7, 8, 9, 10, 11, 12. And I'm going to go down -1. And then I'm going to connect those. And I'm going to do the same thing over here. I'm going to go a -1 away and a negative times a positive. So I'm going to be going up to a positive 12 away. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. -2. And then I'm going to go up 6. 1, 2, 3, 4, 5, 6. I'm going to go -3 away and -3 and 4. 1, 2, 3, 4. -4, +3, 5, 6. So -6, 2, -7, -8, -9, 10, 11, 12. So -12, 1. And then I'm going to connect these. And what you'll notice is it flipped the graph. The graph has been flipped. So instead of it being where our original graph was, like it was, in this case, pretend like this is my XY axis. It's not in quadrant 1 and quadrant 3, if you want to think about it that way. It's in quadrant 2 and quadrant 4, okay? Because now I'm not doing positive times positive and negative times negative. I'm doing positive times negative and negative times positive. So the ones that we're going to see a lot of are going to actually be having a 1 on top. So we're going to have a vertical asymptote at x equals 0. We're going to have a horizontal asymptote at y equals 0, and our locator point's going to be at 0, 0. Because really, I'm trying to think of two things that multiply to 1. And again, 0 times nothing is going to get me a 1, and same with the y. So my x and my y cannot be 0. So I am going to have a locator point at 0, 0, okay, at 0, 0. And then I am going to have a horizontal and vertical asymptote at y equals 0 will be my horizontal. X equals 0 will be my vertical. And then from here, let me just label them. So this one is x equals 0. This one is y equals 0. Then from here, I'm basically going to be thinking about things that multiply to 1. Now, there's a lot of things that multiply to 1, any number times its reciprocal, but the only number I'm going to expect you guys to give me is 1 times 1, so that point right there. Now, really, you could do 2 times a half, or a half times 2, 3 times a third, and so forth. But the only one I'm really going to expect from you guys is this one that is basically 1, 1. And -1, -1, because a -1 times a -1 is also a 1. And then we're going to draw our graph, and we're done. So again, if we have a 1 on top, I am only going to really need 2 points. 1, 1, -1, -1. Now, last graph. Let's say we have a 1, but it is being shifted. Okay, so we are going to have our vertical asymptote at what makes this 0. So that's going to be x equal 4. We're going to have our horizontal asymptote at the plus 6. So I'm sorry, I don't know why I'm writing plus 6. Y is equal to 6. And then our locator point is going to be 4, comma 6. And that's where these two asymptotes are going to intersect. So I'm going to go to 4, comma 6. So 4, comma 6, that's where my locator point is. I am going to be drawing asymptotes through that. So I'm going to have a horizontal one at y equals 6. I am going to have a vertical one at x equal 4. So this is going to be y equal 6. This one here is going to be x equal 4. And then the only 2 points that I want you to be accurate with are going to be going where they intersect at the locator point over 1, because, and then up 1, because 1 times 1 is 1. And then going back here and going -1 times -1 is 1. And then you can just draw the 2 branches. So there's one branch, and there's the other branch. So hopefully this helps you figure out how to graph any reciprocal function graph.